talk you find the electron configuration for an ion. So let's start with nitrogen. Suppose I want you to find the electron configuration for a nitride ion. Well, there's a few things you've got to be able to do in order to make this happen. One, you need to know the charge of a nitride ion from its location on the periodic table. Plus 1s, plus 2s, plus 3s, minus 3s, minus 2s, minus 1s, and no charge at all. So nitrogen is a minus 3. So that's N becoming N minus 3. So we got to understand this means add 3 electrons. Electrons are negative. If you add negatively charged things, it becomes negatively charged. So add 3 electrons. So how do you come up with the electron configuration for this? Don't take any shortcuts is my first advice. Here's what you do. Write the regular electron configuration for the neutral atom and then change the configuration to make it into an ion. So here's what I mean. Start with nitrogen. Let's see. 1s2, 2s2, 2p1, 2, 3. So 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. It becomes an ion when you add 3 electrons. We add the 3 electrons here. 1s2, 2s2, 2p6. So that would be your final answer. That's the electron configuration of nitride ion. So this goes for adding electrons and subtracting electrons, though first, go ahead and try for practice the chloride ion. Go through this process to find the electron configuration. Pause this video now while you work on it, or listen to it as I work it out, and then you can resume playing when ready. So chloride ion, we understand that means from chlorine to chloride with a -1 charge. That means gain 1 electron. So what's happening here? Chlorine, we look at the periodic table to find the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p1, 2, 3, 4, 5. So 1s2, 2s2, 2p6, 3s2, 3p5. So chlorine, 1s2, 2s2, 2p6, 3s2, 3p5 becomes chloride ion by adding an electron. That's 1s2, 2s2, 2p6, 3s2, add 1 electron here, 3p6. One thing to notice, and I can show you some other examples of ions. This is out of at least what is at this moment the current version of the notes. If you need to make it positive, you subtract electrons, even if that means having a configuration of 1s0. Lithium ion, 1s2, beryllium ion, 1s2, boron ion, 1s2. Ions tend to have the same configuration as, this is the same configuration as a helium atom. These ions all have the same configuration, nitride ion, oxide ion, fluoride ion, as an argon ion, or sorry, it's just a neutral argon. Reason why? Atoms are most stable when they either have a full or empty, or sorry, when they have a full outer energy level. These guys develop their full outer energy level by, in this case, getting rid of this level 2 s electron to have just this level 1. Why not add an electron to make this 2s2? Because the energy level 2 also has p orbitals. So in order to fill energy level 2, it would have to have 1 electron to fill this s plus 6 more for a p orbital. So adding 7 electrons is a lot more work than just losing 1, therefore lithium will just lose 1. Whatever involves moving fewer electrons around. Beryllium, easier to lose 2 than to add, what was it, 5 maybe? No, than to add 6. Here it's easier to lose 3 than it is to add 5. So that's why boron is going to lose these 3. Likewise here, it's easier to just add 2 more instead of losing 6. Or here it's easier to add 1 more instead of losing 7. So that's why you're going to see these ions all have the same configuration. It's because they have a full outer energy level, which is just like argon or any other noble gas will also have a full outer energy level. Things are most stable with a full outer energy level. But unlike the noble gases, which are neutral and have no charge, these do have a charge, which means they'll stick to stuff and interact with stuff. And that's why these react and this doesn't. Because if it's neutral, it doesn't react with anything. Whereas if it has a charge, it can be attracted to stuff and stick to stuff. All right, hopefully that makes clear the general ideas of how it works when it comes to ions. Let's look at, let me see something here. I think I have some practice that might be helpful for you, the viewer. Yeah, I guess so. I accidentally have all the answers typed here, but nonetheless, right there, that's something to practice with. So I'd suggest pause, practice with these, and then I'll reveal the answers. Ready? And there you go. All right, there we have it.